Hello, everybody. This is Alec Miller from NarrativeWave. We're excited to talk to you about digital automation for offshore wind. I am the VP of Product here at NarrativeWave. My background is about 15 years experience in the energy sector and the last several years with NarrativeWave doing analytics. I'm excited to introduce Arwell Jones from RWE. Arwell, do you want to give an introduction about yourself?
Yeah, sure. Cheers, Alex. So I'm Arwell Jones, and I'm a service manager for RWE. I've got over 8 years experience now in the offshore wind industry. Prior to that, I was working as a mechanical engineer in a manufacturing plant.
Great, thanks. Maybe let's start with a bit of background about RWE, if you would, Arwell.
Yeah, sure. So RWE, we're one of the world's largest providers of renewable energy. We have a 13 gigawatt renewable target made up from solar and wind, and we've got a goal to be carbon neutral by 2040.
Okay, fantastic. So maybe set the stage a bit, if you would, Arwell, about the background and sort of the challenge that you were facing that led you to look at a digital solution.
Yeah, so recently we've been fully backed by the OEMs in terms of operations and maintenance, and now we've moved into a self-perform strategy.
Okay, that's great. And let's talk a bit about, what are some of the, benefits you were seeking in doing that?
So what we really needed was a bit more control, better holistic management of the assets, and some financial, better financial commitment control, really.
Okay, yeah, some pretty clear benefits there. What were some of the concerns, some of the challenges you needed to overcome to get there?
Just the sheer volume of faults that we expect to see, and using the knowledge effectively to ensure that we can drive a first-time fix rate to the turbines.
Okay. All right, great. And so, maybe focusing a bit down more, what were some of the technical goals that you wanted to accomplish along the way here?
Yeah, major components are something that's really well covered in this industry due to the risk. But gaining consistency and clarity over the day-to-day issues is something that we needed assistance to action. There could be 100 ways to fix a fault, and we needed the analytics to help us gain control and clarity to ensure that we get to the first-time fix. So we needed to build up a knowledge base over time using analytics to move from preventative to proactive maintenance, and then focusing on the right things that add value. Automated corrective actions gives us the best opportunity to achieve a first-time fix. And then, so we partnered with NarrativeWave to put this into action.
Okay, great. Thanks, Arwell. So just a bit about NarrativeWave. We're a software analytics provider that works across multiple energy verticals. In this case, wind and solar and geothermal, as well as water and wastewater. And really our goal is to help renewable energy operators, use analytics and automation, more effectively to improve automation. So as we talk about the solution, we wanted to really talk about the four major components of the solution that we put in place to solve the problems that Arwell has mentioned. And so the four major components really starts with an analytics engine. In this case, that analytics engine is focused on, bringing in this volume of data, figuring out the correct tags, the correct format, and then moving it over to a rules engine. And those can be simple or complex. In this case, those rules are assigning the right corrective action to the right turbine and the associated fault codes. And then those are creating events where you can put those into operation, so you can assign a workflow to the faults that have triggered. You can assign corrective actions to those. And then lastly, you can add knowledge to the solution in a feedback system that comes both from engineers as well as field technicians. And so putting these four components together is the way that we partner with RWE to meet the challenge that they had. Okay, and we're excited to show you this actually. We have a product video demo that we would like to show you. So we're going to go off webcam and move over to the demo and show that to you. Okay, and so let's kick off our demo. Okay, so we are here inside the NarrativeWave solution. This is the events main page. And let's take a look. We have two events here. First of all, what is an event? An event is the representation of an alarm or a fault or something from SCADA data. And we have two of them here. In this case, these are from alarms. And the first goal of the solution here is to compress things that are happening over time into single events. And that's because we need to help manage a large volume of information and do it very efficiently and make it easy to do. So we have two events. You can see that this one started some time ago and is in fact still ongoing. And the solution is creating a single event from something that might be happening over and over again inside the data, okay? The second thing that we need to be able to do with an event is to either assign it a workflow status to know what are we doing with this and where is it in our process. And the second thing is assign it to somebody to follow up on to make sure it's being taken care of. Okay, so this is the first goal of this dashboard page for the events. Let's click in and see what's happening on this particular event. Okay, so the first thing is we're here inside this particular event that is around fault code 4100 about gear oil temperature. And we want to see what's happening on this so we can, pick the right corrective action. So the first thing is we can see, what has happened in the past for this turbine for this particular alarm and event, okay? And so we can see previous occurrences here. We can see a representation of this event over time. It gives us a quick and easy way to see what's happening, right? See if we can understand this event, and then we can take a look at corrective actions and how to fix it, all right? So let's take a look. We've reviewed, when this event happened in the past. We've taken a look at the representation over time. Let's take a look at what we do to fix this problem. And you can see here that we actually have a list of corrective actions. And we have 1, 2, 3, etc., all the way up to 5 different corrective actions. And these come from the people who are closest to the solution. So these are RWE's recommended corrective actions for this problem. And they have a ranking to them. So we can see that we should maybe try this one first and this one second, okay? So this helps us really decide quickly what we should do about this in a consistent and repeatable fashion. The other piece that's important is that you can add knowledge to this solution over time. And in fact, we can do just that. We can add new corrective actions here very easily, which lets us put our knowledge in here if we have another solution to try, and then it becomes part of this database, which is growing over time, okay? The second thing that we can do is we can also start to score these corrective actions in a very unique way, which is asking, in the past, have you tried this action and does it tend to solve the problem? So in this case, we can see that this action was already tried for this particular event, and in fact, it didn't solve the problem. The one that solved the problem is down here, which is corrective action number 5, which is replace the IO board. Now, if this solution up here starts to work, the solution will take this feedback and actually rescore these corrective actions. And so you can see this is a dynamic scoring system, the goal of which is to automatically suggest the most probable corrective action or actions. And in this case, there's 2 things that look like they most often solve the problem here, okay? So we're doing lots of things. We're compressing information here. We can see the previous occurrences. We can see the history of this event. And then we can see the very rich context that builds over time, which is what should we do to fix the problem? So a technician in the field could look at this list, could follow that order of the things there, and can even score them and say, yes, I tried this. Yes, this tends to work. And now next time this event happens for that same alarm code, this list of corrective actions will be here. And then we can follow those and get the right fix the first time, which is our goal, right? And so this is how this works. And we can do lots of other things going forward, like create features from this, mark the data so we can use it in other analytics. But this is really getting us to our goal of making an easy to use system, focusing on corrective actions. Let us solve this problem in the fastest, easiest way possible. Okay. Well, we're going to go back on webcam now, and we hope that you enjoyed the product demo there. We were excited to show that to you. And we wanted to talk a little bit now about, what are some of the outcomes that, people can expect using a solution like this. So, Arlo, maybe you can give us some context. What are some of the areas and details about where you see value coming out of this?
Yeah, sure thing, Alec. One of the value-added outcomes would be time. So we've created an automated standardized response to faults so we can react faster. This saves time both onshore and offshore, deciding how to respond and even simplifying time to get ready. The second is operations. So we're simplifying the operations. We're focusing on the most probable correction action, and then this creates values in an additional few ways. The supply chain and stores, so we can focus on having on the right parts in inventory and ready for the turbine to be issued with the parts to be fixed. Having the right kit on the turbine ready, so this reduces costs and complexity, reduces the repeat visits. And then knowledge, so it's important to have a system where we can capture our knowledge both upfront and over time, and then use it to improve asset and performance and operations. Having the ability to continually provide feedback from the field, for example, is critical as well. So process, lastly, our goal overall is to continue to improve our process, standardize our responses, and use the data to do things like quantify the time it takes to fix the turbine. We think that the more we use the system, the more areas of process improvement we can uncover, and then focus more on value-added tasks.
Okay, great. Yeah, thanks for those details. Well, we want to thank everybody for your time. We hope you enjoyed the presentation. If you'd like to see more details, you could go to narrativewave.com/RWE case study, as you see here, and download a case study about what we achieved here. So thanks everybody for joining us.